Should you use threads? Yes, you definitely should use threads. And that's actually the first thing that I'm going to show today is an implementation of socket-based communication using threads. The reason why you want to use threads is because typically you would have the idea of multiple clients connecting to one server, right? Or a few server. In this case, we can simplify a little bit things. So imagine that you have a single server and you have potential clients that would connect against that server. So the server provides a service, and you don't know how many clients would be using that at the same time. So then this is not a peer-to-peer paradigm. This is a client-server paradigm. So you have potentially multiple clients talking to the server, and not only for organization, but also for processing. So imagine that you have, most likely you would have like completely different states, right? So imagine that you actually have two different persons connecting against the same server. Typically that would not be the same state. So you would have separate states. You want to have that different game happening at the same time for different players, right? So you don't want to have the same game being provided to the different players. Another reason is because anything that would block the execution of one related client, if you have a single thread, will be blocking for every single client. So that's definitely not desirable. You want to have each thread taking care of a client, because then the execution related to each client would be followed as it should, right? So you would not run into the chance of having a block, or you can even run into a timeout if an operation is just waiting too much to complete. It might be the case that you are even using the wait call on the thread. So if you have a wait call and you have multiple clients in the same thread, so then this means that all the clients would be paused while you actually probably intend for one single client to be paused, to be in the wait state, right? So typically the way that we implement a client server architecture is by launching one thread on the server for each client that would be connecting against that server. All right. Now let's take a look at the of these code examples here. This is the knock-knock example that we have shown last time. And let me run this thing one more time so you can refresh your mind on what that is supposed to do. So I run the server. I need to specify, did I specify already? Giant line. Yeah, I specified the port here. And then I need to launch the client. I should have, yeah, I have that saved as well. So most likely we're getting the host name, yeah, and the port as the parameters, right? So again, you need to match that port, otherwise these will not work, as we saw before. And then I have the client expecting a message to be typed. Who's there? So I'm not going to use the question mark, and I should get an error message. And if I use it as I'm supposed to, then it would keep responding, right? And playing that thing, that game. I don't know if you can call that a game. Anyway, that's dynamic, whatever. Okay, we saw that already, right? So now that we have a sense of what the game is about, let's take a look at the code. So on the client, as we saw, I am checking for the arguments that I need, host name and port. I'm saving those. And then I am initializing the resources that I am going to use to read and write. And reading would be equivalent of receiving messages, and writing would be equivalent to sending messages, right? So here I am setting up a socket instance by calling the constructor with the host name and the port. And then I will be setting up the print writer. In this case, I am using the get output stream from the socket that we saw already. In this case, I could have used the. Oh, no, sorry, no, that's correct. And then I also am using. And I'm also sorry. Here I initialize the socket, right? So then I'm creating the writer, and then I need a reader. So the reader would be created here in a similar fashion. So now instead of getting the output stream, I'm getting the input stream and passing to the input stream reader. Why do I need to do that? Because this buffered reader constructor expects a reader object, right? So I cannot pass an input stream, right? Remember? Okay, so and all that is inside the resource block because I don't need to worry about closing those streams, right? If I use it that way. So here I am initializing another stream related object. So this is just to read from the system in the standard input. So this would get the whatever things that I type on my keyboard, creating some strings to store what's coming from the server and what is being typed. So as I receive messages from the server, that would result in these not being null. So then I would print whatever I got from the server. Then I would check if this is a specific kind of message, right? So this is a specific message by, so then I would just break from that loop. If not, I would be reading whatever is being typed in the keyboard. And then I would check if whatever has been typed is anything meaningful that I can use. If it is, then I would be sending that message that has been typed. I would print it in the terminal, and then I would send using my related output, not output stream, the writer, right? And why is it that I'm using a writer and not an output stream? What? Yeah, but why not? Like an output stream would also send data outwards, right? So why not use an output stream? Because it's a byte level data and I'm dealing with messages that are just characters, right? That I'm typing. So it's more convenient to actually use the combination of readers and writers in that case, because then I deal with the character level data instead. Right, because it's text. That summarizes way better than I did. So we have a few exceptions being treated here, and then that's it. That's all that my client is doing, right? So let's take a look at our server. And here we are going to see something interesting and a little bit different than what we had with our previous example. So my server, same idea, would check for the arguments. So I would specify a port. The client will need to use the same port, right? Otherwise, that will not work. The port is being stored here in that integer. And then I would have a state representing if I am listening currently or not. So it's actually not directly being used, but anyways. So then I am setting up the same way that I did before, a server socket to put my server in the listen state. So after that, then my client would be able to connect and then exchange messages among those two. The new thing that we have here is that I would now launch a thread object, and that thread object would receive a reference to my server socket instance. So when I call accept on that server socket, then this would be a blocking method until the client actually connects, meaning that I would not pass this portion of the code here until the client connects, right? That's an important observation. And then finally, after this happens, after the client connect, and then I set up a socket, and I pass the socket to that thread object that I'm creating. I would call start on the thread to allow it to run. And then eventually the scheduler would pick up, depending on the scheduling decisions that the scheduler is doing, right? So it would eventually pick up that thread and put it to run. So now let's take a look at these thread class that we are specifying here. As you would expect, these extends for thread. I have the constructor that is essentially just receiving that socket object that came from the accept method. Then I'm calling the super constructor. So this is just to name the thread. The super in this case is who? Thread, right? And then I am saving the reference of the socket that I have received in this field that I have here. Okay, so now I have the reference to that socket that has been created, that has been passed by my accept method. And then in my run method, that's when I would have all the logic on the server side happening, right? So it's essentially the same idea as what we had in the previous example, but now I have a thread being launched every time that I have a new client connecting to that server. And now my server is a multi-threaded server. If I would not do that, when I call accept in a single threaded version, the server would be only able to respond to one single client. So it will not be able to respond to multiple clients at the same time. Okay. Any questions?
In that case, once someone will be responding to, let's say, one client, what will happen to the other?
It would be waiting until either the first client finishes and then it's available to keep going, the server is available to keep going, or it would time out. Because this is like a long interaction, right? So most likely that would just time out depending on the timeout that you have set up in the operating system of the client.
Server socket.accept it forms a connection. So does the client information is in the form of IPv6 packet?
It might be v4 or v6 depending on the underlying protocol that is being used. So Java supports both v4 and v6. So if that package was received via IPv6, that will be available to you. If it is received via v4, it is also available to you. Both are implemented. Very old version of Java would have support only to v4, but it's been a while that v6 is supported.
Basically, server side should support both because like clients may be different Java version, server may be different Java version.
So I'm talking about versions of the TCP/IP stack, right? So the IPv4 is the version of the IP protocol. It's not directly related to Java. Java, however, needs to support the Java classes, socket and server socket, needs to support the underlying protocol. Who actually implements that is the operating system, the IP protocol. Did I understand your question? Yeah. Okay. So same idea as what I had before, right? So I'm setting up my resources. I'm gonna get a writer from my get output stream method. And I'm gonna get a reader from my get input stream method, right? Coming from the socket. And then after this is set up, then I can just use the regular operations for readers and writers to essentially send and receive messages. So here I have 2 strings. There's another new thing that we are doing here. We are instantiating this protocol class. So this protocol class would essentially abstract a little bit on the kind of messages that would be exchanged between the server and the client. And this protocol class provides this processing method that would take my input and then output that in that string. And let me show this. Do I have? Yeah. Let me show this class here. So then we can just go back to where we were. So here, this is the protocol implementation that I have. So I'm just setting a bunch of constants. This usually represents states or things that I would be using as you are used to setting constants, right? So for instance, waiting would be one of the states that I can have my game at. I have some strings here. That would be the message that the server would be sending to the client, and then it would be expecting. It would be sending back these messages if these are matched, right? So the client would send the message, the server would check if the message is what is expected, and this goes in sequence. So you need to follow that sequence, otherwise it would just roll back to the beginning. And this is the main method that would process your input. So you would work with states. You would begin at the first kind of message. You send knock knock. So then you change the state to right after send knock knock. So then now you expect that first message to be sent, right? So expect the who's there to be sent. Otherwise, you would complain and send that message back to the client. If you do get that, then you would be getting setting the output to that clue that we saw. That would be in this case, the first one, the first string. And then you keep doing that, essentially going over the states, right? It's just a basic finite state machine implementation where you move to the next state. If you fail the condition, you go back to the beginning, the very first state. Any questions on this code, this implementation? You know what a finite state machine is, right? Everybody knows what?
Yeah.
Okay. I think you saw in 6.6.6.1 there, right? All right, so we have a sense of what the protocol is about. Let's keep going with the server side, right? So here I would be receiving the potential output after all that method executes. And then I'll be sending that to my output, to my writer. Again, when I call print line on that writer, under the hood, the operating system is setting up the packages on multiple layers of my TCP/IP stack, and then that is being transmitted to the client, and then the client is receiving. The operating system on the client side deconstructs those messages and then extracts back the actual content, the payload of that message with that string that we have transmitted. And then here I'm just going over and checking the input, the messages that are being received from the client, right? Then I am calling again the same method, now passing the message that you have received, and then that method will tell what the output should be. I transmit that output, and then I do that until I get the die message, or until these actually return null. And then that will break that loop, and then I would have my run method finished. Do I need to call close here? Why? Was it?
Other clients are being connected to the same server, they can't communicate.
So socket is socket here. Yes.
Because printer closes the whatever items there, right?
Yeah, so the close would be called on out and in, but what I'm really focusing on is the socket, right? So this would actually, and because I have the auto close mechanism being done by my print writer, so I could actually not even that explicit close method being executed. Okay, it doesn't hurt to have it though, right? So it's not something that would affect in any way. Any questions on the code? So now, what differs from the last example that we have? Now we have a multi-threaded server, and we have another class that is taking care of the protocol of the kind of messages that are being exchanged, right? So mainly for organization, it makes sense to have like a separate class to do that. Yes.
If closing the socket, how would the remaining clients try to talk to the server?
This is just one client. Each thread is associated with one client. So this one socket is related to that client and not to other. So you might have several sockets open, one for each client. If I close one, I'm just closing one specific.
How is this socket automatically closing? I didn't exactly get that.
Because you have, so when you create, because these objects here are inside the resources block, so all these objects would be automatically called close.
Like
So-
socket is not declared over there, right? The specific socket that we have.
You would call close on this object and on this object.
Yeah.
But this object here was built on a socket object.
Socket,
On a-
so like even though we are like calling the output stream, like it is associated with the socket object itself.
Actually, I'm sorry, you're right. In this case here, because of the way that I have created that inner object, so that would not be propagated to the socket. So I do need that explicit socket here. Yeah, good observation. Yeah, yeah, you're right. Yeah, right. Yeah. So if I would have like a new some object, some input stream, so that would the close of the outer one would be propagated, but that's not the case. So in that case, you actually do need.
Instance is created within the try block, then only it will get closed.
Right. Yeah. I guess you can also add socket. Yeah, you can actually do that, and then you would have inside the resources block, right? So Mohammed is actually suggesting that we could explicitly create a socket object. So then this one would be called close because it's inside the resources block. So then in that case, I would not need that line. So that's also a fix for that. Thanks, Mohammed. Any more questions on this example that you have here? Now let's move on to our next example that, oh, by the way, I did not mention, but it's an important thing. For the homework, you can fully use sockets. You don't need to implement the datagram-based communication, okay? So you actually, based on the examples that I have shown here, you already have everything that you need to have your homework completed. But let's move on to our last example on networking, which is based on the datagram socket class. So here, this is going to be a program that does something very similar to the knock knock program that we had before, but this would essentially just be an empty message that is being sent by the client, and then the server would respond with a quote that it would get from a text file. And that would be just repeated for 10 times. That's the main loop that I have here. Now I want to use datagram sockets. Datagram sockets are the implementation in Java of the classes that utilize UDP. So you no longer have the idea of connections. You don't have that idea of the initial setting up that needs to happen between the client and the server, actually from the client to the server, right? That would do that handshake, and then that would create that connection. And then from after the connection is created, then you can have the messages being sent and received over that virtual pipeline that the connection is. Because I don't have that, then I don't have the guarantee that the messages would actually be delivered. So if I send a message, there's absolutely nothing that guarantees that the endpoint, the destination, would actually receive that. All right?
Will it be sent to a certain port, or that's not even there?
You need to match the ports. Yeah, you cannot. So the same idea of the port happens between the client and the server. So you would need to match when the first message is sent, right? When let's call it client, but actually there's no distinction between the two parties in this case, right? Let's call it actually A and B. So when A sends the first message to B, so then B would know the port associated with A. But A needs to know the port where B is listening. Otherwise, there's no way, right? Okay. So, all right, so here I'm just declaring the socket. Notice that here, this is the client, right? So actually let's go with the client, then we go to the server later. So I would be calling, I would be setting up a packet for using another class called the datagram packet. So it's associated in the same datagram, the set of classes related to UDP, right? And I'm just using a buffer, which is just an array of bytes, to initialize that. Notice that here I need to specify the address and the port for that packet. So that's something that is already being set in the packet. I'm not sending the packet just yet, but it is set up in a way that it already has that information. Okay. And again, that what I mentioned before, the server would need to be listening on that port to be able to receive that message. If it's not, nothing, like no error message of any kind will actually happen, right? So there's no confirmation in the receipt of those UDP messages. So when I call send on that socket now, and I pass the packet that I created, now I am actually sending that over the network. So I'm being a little bit more explicit than the way that we were using with sockets, right? As I said, you would need to have the server waiting for that package. Otherwise, it would just be lost, and you would have no indication that actually happened. Okay. So after you send that, so this byte was not set in any way, right? So this is just some non-initialized set of bytes that you are transmitting. Then you would be getting this would be more like a signal, a trigger for the server to know that the client now is expecting something in return, and that's what you would be doing here. So it would be the same idea, initializing a datagram packet. Now you would be calling on that socket that you created the receive, and then you would be receiving and writing that data into that packet. The same idea, I'm reusing the same object, but now I am actually not sending, but receiving the message from the other party. Okay. You can call the other party server, but as I said, actually there's no really distinction between the client and the server in this case, because you don't have the server being the one that is waiting for connections to be established. Okay. Then you process that. So you call get data. You create a string from those bytes that you receive, and then you print that in the terminal. So then you receive whatever has been received here. So you print that in your terminal, right? So nothing super fancy here. Any question on that so far?
If the server doesn't send the packet, it will be a blocking thread until like it sends the socket to receive packet.
Yeah, the receive, yes. The send, I'm not sure, because the send you could actually postpone that. So I don't think that would be a blocking one. Yeah.
So receive is the
Most IO operations are blocking, but there are some exceptions, right? So the receive needs to be blocking because some things needs to happen before I would be able to go ahead and read from that given buffer that represents whatever you receive. But the send is a different story, right? So the send might just mean that the JVM has called an API on the SO level, and then that's it. So it might be the case that the message actually did not actually, was transmitted before JVM can move on, can continue. Okay, so I'll need to check just to be sure, but most IO operations are blocking. Mohammed is asking, actually, there's two questions here. So does datagram imply UDP? Yes, datagram implies UDP on the Java world, and the server could actually be single threaded here, right? So I did not show the server yet. And in this case, I believe I am not doing multi-threaded because this is just a peer-to-peer, point-to-point connection, right? So there's really no idea of the client-server architecture. So even calling clients and server is to some degree debatable because you don't really have actual a client and a server. You have two peers that are sending and receiving messages, right? So depending on the sequence of messages, right? So you can consider one to be client, the other server, but it's not the same as having actual clients and clients connecting against the server.
In this case, there won't be a case where there are multiple clients for this matter.
So you could implement, in this example, I don't have that, but you actually could have that case as well.
Because there's no point of connection, right? So anyone could contact the server.
Yeah, in this case here, the server is just responding, is receiving what we are calling the server is receiving a signal, an empty packet, right? And then it's just sending a quote back, right? So it can actually do that for multiple different parties sending messages. As long as all these parties know the port number on the quote server side, then it should be enough for the server to just launch threads and then respond to those requests. Okay. Did I answer your question, Mohammed? I hope so. Okay. So what's left for us to see is the actually in this case I didn't realize, but we are using threads. But as you would see, we don't really need that because I'm only communicating between two parties, right? So I'm actually here in my quote server. I am launching that single thread here, right? So it's not really the same as the multi-threaded server that we saw before. Okay. I probably would even simplify that and just create a single class. Anyways, so here in the server, I am creating the datagram socket. So same thing, exactly the same thing as I had in the client. So it's not, so in the socket world, you have the server socket and the regular socket. So they are not the same classes, right? Here in the UDP world, you have essentially the same kind of classes being used on both sides. So you set up the socket, and then you set up some reader here to read from this file, and then you go through the main run method, and then these would, where's more quotes coming from? This is just a Boolean, okay. So while I have this state equals to true, then I would set up the buffer. I would do exactly the same thing as I did before. I set up a datagram packet. I need to pass a buffer for that. And then I would receive first the packet. So recall that in the other example, in the client example, I sent first and then I received afterwards, right? So here I am receiving first, and that's obvious, right? Because the other just sent something to me. And then after I do that, this is blocking, right? And then after I do that, only after I receive the packet, I would go ahead and I would generate, what is that? The date. If my input here from this file is empty, then I would just get the date and convert to string and then return that. Otherwise, I would call the get next quote to get the next quote from that input string. I set up the buffer with that string that I have set, and then I call send here. However, there's one new thing here that we did not see before. So when I set up the datagram packet before, I have set the address and the port based on the arguments that I have received from my command line invocation, right? Here, I don't have that, right? So here I have the case of a client that connected against me. But then because I have received that packet, I can actually extract that information of the IP address and the port associated with that packet that have been received, right? So that's what's happening here. I am extracting the address and I am extracting the port from that packet that had been received back in the beginning of the method here.
TCP the internet does the same thing, right? It's that I accept method where something that gets a packet.
You can do that, but you don't need to do that. Right?
Explicitly, but internally.
Yeah, internally it does that, right? That's correct. Okay, but in this case here, because I want to send the response back to whoever sent me that package, right? So I need to extract that in an explicit fashion, and that's how I extract those two information, and then I feed to that new datagram packet, and then finally I send that back to the original sender, to the other party. Does that make sense?
What was the empty string that we received?
In this case, buffer is not empty because that's the response that I am setting up from that screen, either with the date or the code, right? So my response is not empty. The package that I have received, it is empty. I don't even treat that in any way in this code, right? But the response that I am sending is that string. Questions? Okay, that's all. With that, I finish the topic on networking. So next class, I will go back to threads and then we will keep going from there. Okay. All right, guys, have a good day.